In this lesson, we are going to have a look at expanding some algebraic expressions, right? So we'll start with very simple examples first. So the first question I have is minus 3 times 2x minus 5, right? So what we do is we start by, I'm just going to start by marking some arrows there. So the first thing I'm going to do is I'm going to multiply by minus 3 by 2x. If I multiply by minus 3 by 2x, right, so that's going to give me a minus 6x, right, and then we are multiplying our minus 3 by a negative 5, right, so those are the two operations we're doing. So minus 3 times 2x giving us minus 6x, and minus 3 times minus 5 giving us a positive 15. So the expression in expanded form is equal to minus 6x plus 15, right, so nice and easy start. Right, so here we have a fraction, minus 2/3, and that's multiplied by 15x plus 4, right? So obviously I'm going to do the same thing. I'm going to draw my arrows first. So the first thing we're going to do is we're going to multiply by minus 2 on 3 by 15x, right? So, and when we do that, we can see the 3 would go into 15 5 times, right, and minus 2 times 5 is minus 10, right, so giving us a final product of minus 10x, followed by minus 2/3 times 4, right, and 3 and 4 doesn't simplify any further, so minus 2 times 4 is minus 8, leaving us with a final product of minus 8 on 3. So the question in expanded form is minus 10x take away 8 on 3. Alright, and that completes that question. Alright, moving on to further examples. Right, this time we're looking at expanding binomial products. Alright, this is where I like to use my arrows in the form of a claw. Right, so obviously the first thing we've got to do is we've got to multiply everything by 2x, and then followed by multiplying everything by the negative 3, right? So in this example, right, I'm going to go straight into the final answers, right? So rather than having to mention those middle steps, because the more we get used to going straight to the final answer, the quicker we're going to be able to solve these questions, right? So my 2x times 3x, 2x times 3x is going to give us 6x squared, and 2x times 2 is going to give us a 4x. And then the second part is multiplying everything with a minus 3. So minus 3 times 3x is going to give us a minus 9x. And then the final multiplication, minus 3 times 2, giving us a minus 6. Right, so we just have one more step left, which is to collect any like terms that we have. Right, and we can clearly notice that we have a pair of like terms, 4x and minus 9x. Right, and that's going to combine to give us, so the first term being 6x squared. Now 4x take away 9x is going to give us minus 5x, and then the last term being minus 6. So the expansion of 2x minus 3 times 3x plus 2 is equal to 6x squared minus 5x minus 6. Alright, the next example, right, so we have two brackets that we have to multiply, but we also have a number in front of the brackets, right? So what we're going to do for the moment is we are going to not worry about the minus 3 for the moment, and we're just going to multiply the two brackets to start with. Right, so I'm going to draw my arrows first. So multiplying everything by 4x and then multiplying everything by 1, right? But having said that, it is important that we keep the 3 in perspective, right? Because at the end of the day, we have to multiply everything with a minus 3. So 4x times x giving me 4x squared, 4x times minus 2 giving us minus 8x. Then we have 1 times x giving us 1x. Obviously when we're representing 1x, we don't have to put the 1 in front. It automatically assumes that there is a 1 in front. And 1 times minus 2 giving us a negative 2. Right, and again I'm going to collect the like terms before I'm going to go ahead and multiply everything with the minus 3. Right, so I can see I have a pair of like terms that I need to collect. So 4x squared minus 8x plus 1x is going to give us minus 7x, and then minus 2 being the last term. Right, so one last step in this question, we are going to multiply everything with a minus 3. Right, so if I multiply everything with a minus 3, I'm going to start by minus 3 times 4x squared, giving us minus 12x squared. Right, the second step, minus 3 times minus 7x. Now two negatives making it a positive, so a positive 21x, and then finally minus 3 times minus 2, giving us a positive 6. Alright, so like I said, the steps are exactly the same as the previous question, except before we get to the last step, we have to multiply everything with the number in front. Right, so that's expanding binomial products there. Right, moving on to further examples. So we've called this this as expansion of perfect squares and difference of perfect squares. So let's start with this first example, right? So we've got two brackets, x plus 3 and x plus 3, right? And I'm going to multiply it just like the way we've done in the previous question, right? So I'm going to draw my arrows. Right, that's going to basically lead us with x squared plus 3x, another 3x, and then the final multiplication, 3 times 3 giving us 9. Right, and if I collect my like terms, I'm going to have x squared plus 6x plus 9. Right, and similarly my next question, 2x minus 1 to the power of 2, right, which is basically nothing but 2x minus 1 times by itself. Right, so and again I'm going to go ahead with my arrows. Right, and if I expand it in that format, I'm going to have 4x squared, then 2x times minus 1 is minus 2x, minus 1 times 2x is minus 2x, and minus 1 times minus 1 giving us a positive 1. Right, one final step, collecting like terms. Right, I do have a pair of like terms there, and they're going to collect to a minus 4x plus 1. Right, so obviously I've used my arrows to expand these brackets. Having said that, right, when we have both the brackets being exactly the same, right, in the first question x plus 3 times x plus 3, which is simply x plus 3 to the power of 2, right, and then the second question we had 2x minus 1 to the power of 2. Now to expand binomial products of this particular format, we do have some formulas, right? So now as we expand similar questions of this type, what you can start to see is you can start to see some patterns, right? And that's where these formulas comes into play, right? And the formulas are in the format of, so if I have my expansion as a plus b to the power of 2, right, and that'll expand as a squared plus 2ab plus b squared. And similarly, if my bracket was in the format of a minus b to the power of 2, that'll expand as a squared minus 2ab plus b squared. Right, so we take down these rules under the title of expansion of perfect squares. Right, and obviously that's because the power outside the brackets is 2. That's why we call them as expansion of perfect squares. Right, now let's have a look at these two examples that we've just done here. Right, so x plus 3 to the power of 2, right, which is following the pattern of a plus b to the power of 2, where the value for a is x and the value for b is a 3, right? And if I was to use the formula to expand, right, the first step in the expansion is to do a squared, which in this case is equal to x squared, and x squared is what we have right there, right? And the second step is doing 2 times a times b, right? So if I apply that to this particular question, so 2 times x is 2x, times by 3 is going to give me 6x, which is the second term in the expansion we have. And the final term is equal to b squared, right? And the value for b is 3, and 3 squared is equal to 9. So what I'm trying to say here is, if I was to use the formula, I could simply expand from x plus 3 to the power of 2 straight to the answer without having to go through the middle step, right? Making it a little bit quicker. Similarly, if I was to apply the rule of a minus b to the power of 2 to this question that we have here, right, so if I was to apply that, right, and I was to expand my 2x minus 1 to the power of 2, right, this is what I'm going to get, right, my first term being a squared, right, and the value for a in this question is 2x, so we're going to have 2x to the power of 2. I'm just going to do a middle step here just so it can be clear, right, 2x to to the power of 2. Now take away 2 times a times b. A is 2x and b is 1. Right? We don't consider b as negative 1 just because the formula already has a minus in there. So the value for a being 2x and the value for b being a positive 1. Right? And my final step is b squared, right, which is going to be 1 squared, right? And 2x to the power of 2 is 4x squared minus 2 times 2x is minus 4x, and minus 4x times 1 is also minus 4x, and then plus 1 squared, which is equal to 1, right? And obviously the whole reason why we use the formula is so we can get to the final answer straight away, right? And you would skip this middle step, right? Once you get more and more used to the formula, right, what you would do is you'll start skipping this middle step and go straight to the answer. Whereas if we are using the arrows to expand, right, we have no option but to do the middle step before we collect the like terms. And that's where the formulas comes into play, right? So a plus b to the power of 2 equals a squared plus 2ab plus b squared, and then a minus b to the power of 2 is equal to a squared minus 2ab plus b squared. Right, one last question I want to discuss in this particular section, right? So 2x minus 2 times 2x plus 1, right? So let's just expand it like we did in the previous sections, right? I'm going to draw my arrows. So if I draw my arrows there, right, it's going to give me my first terms being 2x times 2x is 4x squared minus 1. So 2x times positive 1 is a positive 2x. Then we have minus 1 times 2x is going to give us minus 2x. And minus 1 times 1 is going to give us a negative 1, right? And again, we have some like terms in the middle, right? 2x minus 2x is equal to 0, which is going to just leave us the answer as 4x squared minus 1. Right, and again, yes, we can use these arrows to expand these expressions, but when we have two brackets in the format of a plus b times a minus b, which is what we have in this case, right? A plus b times a minus b, that can be expanded by simply going a squared minus b squared, right? The reason being the middle two terms, when we use the arrows, as we noticed, they cancel out each other. So 2x minus 2x is 0. So all we're left with is a squared minus b squared. And we call this rule as the difference of perfect squares. Right, and we use this formula when we have two brackets in the format of a plus b and a minus b, right? So, and we could have used that formula straight away for this particular question, right? So a is 2x and b is 1, and 2x to the power of 2 is simply 4x squared. Take away, right, b is 1, 1 squared is 1, right? And if we were to use the formula, we could achieve the answer in straight away one step, rather than having to expand and collect like terms. Right? You can still do that. You don't necessarily have to use the formula, but the formula is the quickest way to achieve the answer. Alright, one last question in this section, expansion of three brackets, right? This is as hard as it's going to get in this particular section, right? So if I was to expand three brackets, right, this is going to take a little bit more steps than usual, right? So what we're going to do first is we are going to expand just the first two brackets to start with. So I'm going to expand the first two brackets. I'm going to put some arrows there. Right, so if I was to expand the first two brackets, I'm going to get x squared, right, minus 3x plus 2x, take away 6, right? And I'm just going to leave out my third bracket as is, which is 2x minus 1, right? And collecting like terms, right? Collecting like terms, I'm going to have x squared minus x minus 1x basically, take away 6, and that's multiplied by 2x minus 1. Right, and then from this point onwards we just continue our expanding again, right? So the first step is to multiply everything with the 2x, and then we multiply everything with the minus 1. Alright, so exactly the same format, except it's just one additional step. Right, so let's do that. So if I'm multiplying everything with the 2x, 2x times x squared is going to give me 2x to the power of 3. 2x times minus x is going to give me minus 2x to the power of 2. 2x times minus 6 is going to give me minus 12x. And now multiplying everything with the minus 1. Minus 1 times x is going to give me minus 1x squared. minus 1 times minus x is going to give me a positive 1x. And one final step, minus 1 times minus 6 is going to give me a positive 6, right? And now one final step is to collect the like terms. Right, I can see that minus 2x and minus x squared is a pair of like terms. Similarly, minus 12x and x is a pair of like terms, right? So we just have to combine all of them together, and that's going to give us our final answer. Right, first term being 2x cubed, there is no other like terms, we don't have to simplify that. For the x squared term, we have two of them, so minus 2x squared minus x squared is going to give us a minus 3x squared. And then the next pair, minus 12x plus 1x is going to give us a minus 11x. And then my last term is the constant, which is 6. Right, and that's all you have to do when expanding three brackets. You expand the first two, simplify that, and then multiply it with the third bracket, and again simplify by collecting like terms. Right, that comes to the end of our lesson today. Thank you for listening, and have a wonderful day.